Steve here with a special animal news report. I'm currently located 1,000 kilometers inwards from the eastern coast. We're in the house of Zachary teasing. The weather here, about room temperature. That makes sense. Come here, I have something truly remarkable to show you. We have a wild calculus student in its natural habitat. We don't want to wake him. Around this time of year, these creatures tend to work themselves out until there's nothing left in the tank. See? The natural fuel source. Let's see what it's working on. Ah, yes, an area down under a curve problem. The way you solve these bad boys is by using the limit process. You find the area of a rectangle and multiply that to a near infinite amount to find the area underneath. Blimey! A wild instructional whiteboard. You don't see many of these anymore. Google Classrooms run these beautiful creatures to a near extinction.
This is the limit process, and this is the equation we're going to be using to substitute our delta x and our c sub I into to give us our area. So our first step is to find delta x, and so we're going to be doing that by using the interval they gave us. And so our 0 is going to represent a, and our 1 is going to represent b. And so we have b minus a, so 1 minus 0 over n, and n is just the number of rectangles that are going to fit into this little space. And so we're just going to keep it there. And so our delta x is going to simplify into 1 over n. And then our c sub I, which is also part of the equation, is going to be our a, which is 0, and our delta x is going to be the 1 over n, what we just found, times I. And so this is going to simplify into I over n. And so our next step is to use the limit process and plug our equation using our delta x and our c sub I. Our next step is we're going to take out the limit because we're going to find the summation and then we're going to find the limit. And our next step, we're going to multiply 1 over n into both terms of this. And so it'll be I squared and n squared over n squared. So we're, instead of leaving it how it is in a fraction, we're going to pull the n squared times the n over here, so it'll be n cubed. We're going to pull it all the way in front of the summation. So it's going to be I over n cubed. And then what we have left over is n, or I squared, like that. And then we have to find the summation of 2 as well. So we're going to have the summation of n as I equals 1 of 2, like this. And so we're going to be using summation formulas to replace the summation of I squared. So it's going to be 1 over n cubed, we're pulling up from right here, times the summation formula, which has already been given to us, which is n times n plus 1 times 2n plus 1 all over 6. And then we have the summation of, oh, I messed up. This is supposed to be, this n is going to multiply over 2 and going to transfer down here. So we multiply the 2 also by 1 over n. And so we're going to have the summation of 2 over n. And so the summation of a constant is just a constant, which is 2 over n, also multiplied by n. So the n underneath is going to cancel with the 1 on the side right here. So they're just going to cancel out whenever we start to simplify in the next step. So it's going to be 1. Oh, also, we are going to cancel out this n here and with one of the n's on the bottom on the denominator. So we'll be left with n squared, and this n will just cancel out. So it'll be n squared over, so I'm going to FOIL this just to save a little bit of time. So it's going to be 2n times n, which is 2n squared. And then I'm going to multiply n times 1 times 1 times 2n. When you add this together, it'll be 3n. And then 1 times 1 is 1. All over 6. And then, since these just canceled out, it's just going to be plus 2 on the end. So, to simplify this even more, in the next step, I'm going to separate the terms on the top because we have a single term in the bottom. So, each of these can be their own fraction. And I'm also going to multiply the n squared times 6. Now we're going to add the limit process back in, the one we cut out in this step. We're going to bring it back in. So it'll be the limit as n approaches infinity. We're going to find the limit in our next step. And so since there's an n in these two terms, it's going to reduce to 0 whenever we take the limit of it. So it's just going to be, we're going to replace this part with 0 when we find the limit. And when you find the limit for a constant, like 1/3 or 2, they stay the same. So we're going to have 1/3 plus 0 plus 0 plus 2. And so when we get our final answer, it'll be 7/3 units. And then since we're finding the area, it'll be squared. And that is our final answer.
Crikey, didn't see you there. Well, kids, that's how you butter your pancakes, and now you got yourself a big old breakfast, and I bet you feel a lot smarter now, too. I think he's waking.
Hey, mister. What are you doing in my house?
Cut. Dude, we need to go. Let's go. Wow. This was truly a remarkable experience. Rarely you get to be so close to these people without being endangered by the teenage angst. And I can't believe I was able to get out of there without being subtweeted at. Well, I'm Steve Intergrand signing off. You go have yourself a Dundee day.
Mr. Cheetah, we'll see you now.
Steve, how many times do I have to tell you it's called the Animal Planet?
I'm sorry, Mr. Cheetah. I really am. I'm at war with myself. Like Newton and Leibniz. I love animals, I do. But I love math more.
Steve, you're a disgrace. Get out of my office! Yes, Steve is gone. Of course I have a new host in mind. Our new show will be the perfect mix of math and animals. Yes, it's time to bring in Mrs. Highland.